All right, so now what we're doing is we have gone through a few of our financial situations, and they've both been either arithmetic sequence, which that means you're adding or subtracting. So an arithmetic sequence where you're adding is simple interest, where you're minusing or subtracting, that was like flat rate and unit cost. Then we had geometric sequences. That was when you were timesing by a common ratio or that number. And remember, we represent it with a big R. And that's a geometric. And then we had we had the two scenarios where it either grows, like so it gets larger, or it decays. Now what we're going to do now, when we move into chapter 8, is often financial situations is a combination of those two types of sequences. And that's what we're going to be looking at now, is always when there's a little bit of a combination. Now there's lots of different sort of scenarios, so we'll start working through it now. So in 8A, what we're going to do is we are going to look at combining linear geometric growth or decay to model compound interest investments with additions to the principal. So what that means is, generally when you go to a bank, and you can see down here, we've got the basic, this is a recurrence relation of that scenario. So you can see this R value, that R value is the geometric growth, because that's with the timesing. And we're going to be, so we're multiplying by a number greater than 1. So what's happening there is you've gone to the bank and you're putting your investment in. And that means you're putting money into the bank. Now, the bank says, okay, I will give you interest on that. So it's compound interest and it's growing. But you don't want just the investment just for that to happen. You're going to add extra because you're saving. So you might be saying, oh, I'm going to take, $50 from my wage each week, and I'm going to also add that in. So when you're adding that extra payment, and you can see here, it's represented in the D with a D, and that, remember, that was like in our arithmetic. So that is like the arithmetic growth, because it is you're adding. Okay, so there's what a recurrence relation will look like. You'll have it multiplying by a number, and then you'll also be adding something to it. So what also, when you have this this compound interest on the calculator up here, and I talked about it, you can still do it recursively on the calculator. So what you could do for this one up here, they're saying to start with 50. So you press 50 and press enter. Then the rule to get the next term, which is here, is you want to times it by 2 and minus 10. And you can actually just do that in the calculator and it'll keep doing it recursively. So you'll see here, it says modelling a compound interest investment with additions to the principal. Remember, the principal is just a way to say the VO, or if you want to write the original investment, yeah? So that's what financial institutions call it, the principal. So Fred has saved $5,000 and invests this in a compound interest account paying 4% per annum. So we're going to start getting used to writing things. So that's my R, remember the per annum, and it's compounding yearly. So that's telling me PPY equals 1. And he also adds an extra 1,000. So now what they're doing when he adds that extra 1,000, that's that D, that extra payment there. And they want you to model this using a recurrence relation. So first of all, before we write out the recurrence relation, we need to calculate this R value. So it's the same as, compound interest R. So remember, it's going to be 1 plus the rate over PPY over 100. So in this instant, it's 1 plus the rate, which was 4, over 1 over 100. So we'll end up with a R value of 1.04. Once you know that, then you can write out your recurrence relation. So remember, a recurrence relation, you have to write what originally it starts with, which is 5,000. Then you need a rule for the Vn plus 1. So I can see up here they've shown me how to do it. So I know R is actually 1.04. Then I'll write Vn now plus, what was D? What was the extra payment every year? 1,000. So then you write that. So that's our recurrence relation there, okay, of that scenario. So to this one, if I was doing this recursively in the calculator, you can do that. So say you want to get the first few terms, you would just press 5,000 and press enter. So this would be in your calculator. So you press enter, and then what you do is you press times, and when you press times, it'll say answer, and you go times 1.04 and then plus 1,000, and you go press enter, and it will be, what would that be? And then it would tell you. So if I did that, I'd get 6,200, and then if I keep pressing enter, I get the next one, and so on, 7448. All right, so you can do these on your calculator as well. If I got to this next example, so Noor invests 12,000, so here's a VO, and plans to add an extra $50 a month. So that is your D value, the extra payment. And the account pays an interest of 3% per annum, so that's my R, but it's saying compounding monthly. So PPY must equal 12. And then they want me to model this recursively again. So once again, remember, you're going to have to calculate that R value. Now, because it's compound interest, the R value is found by doing the 1 plus the rate over PPY over 100. So in this case, it's 1 plus, what was the rate? 3%. Over 12, because it's monthly, over 100, and I get 1.0025. Okay, so now I can write out my recurrence relation. VO was 12,000, and Vn plus 1 equals 1.0025. There's the R, Vn, and then I have to add the D, which is 50. So this was given in monthly, like the payment is a monthly payment. So that's okay. So they won't mix that up on you. Yeah, if you're, I can see what you're saying. What if they said you're going to add 1,000 a year? Normally your extra payment will be told and it will match your compounding interest. So Albert has an investment that can be modelled by this recurrence relation, where Vn is the value of the investment after n months. Okay, so this is a monthly formula. So sometimes it's just good to write that because you might forget. In case they ask you something about, what's happened after a year, you would need to check after months. Okay, so with A, we're looking at that recurrence relation, and what's it saying? It's saying state the value of the initial investment. It's very easy, these questions, but they're just checking that you understand what a recurrence relation is. So what was initially invested? Yeah, $400. So because VO is 400, and originally it was 400 was invested. So B, now it says determine the value of the investment after Albert has made 3 extra payments and round to the nearest cent. So it didn't say show recursively, so you don't have to write all the steps out. So here you could probably just do it on your calc. So when you do it on your calc, you would chuck the first number in, 400, and press the enter. So if we go, we press 400 and we press enter, we ended up over here. And then because it says after 3 extra payments. So the first one, when I say times, answer should come up. And we're going to times it by 1.005 and add 30. And when we do that, we get Okay, when we do that, we get 432. So that would be the first payment. And then you just can keep pressing enter and you should get the next one. So the second one was 4641.16. And then I press enter again. This would be the third payment, which ends up being 496.48. Okay, and it did say round to the nearest cent, so they have reminded you that. So that is actually the third payment, and that's actually V3, which is what they're asking for. So you don't have to show all that working out because it doesn't say recursively, but I'm just showing you how you type in the calculator what you would do. And see, what is the value after investment after 6 months? We're already on V3, so you just keep pressing on your recursive calculator again. So I go V4, 5, and 6. So when you do that and you get up to V6, we end up with 594.41. Right, so at this point in time of your textbook and what you're doing, you would just recursively be getting up to V6, meaning just keep pressing enter. You know how we've had the nth term before for other things? When we start having combinations like this, we no longer do that. What we're going to be using is Finance Solver. And that sort of incorporates all of that. Because you've got to remember, you've got to add a payment in every time. So it gets a little bit more complex. You could do it, but they don't ask you to know that. You just have to know Finance Solver. They're actually teaching you that. All right, that's 4.2. Okay, determine the annual interest rate. So when they talk about that, so when you read these things, you should highlight and they want you to determine the annual interest rate. So put rate and a question mark. That's what they're asking you for each of the following investments. So if you have a look at A, now you know when you have this value here, that's the big R or the common ratio. In that formula is the rate. Remember? So we go rate over PPY over 100. So what you could do if you wanted to, you know that R in this scenario is 1.005 and you could put the formula here. Now this says after n months, so PPY equals 12. So I would do the rate over 12 over 100 and I can do into my calculator, I can go solve, comma R. And I end up with a rate of 6% per annum. Okay? So you could do it like that. The other way you can look at it is obviously see how we have the R is this 1.005. Okay, this part here, I need to do it. This part here is the extra interest percentage, really, isn't it? Yeah, that's the extra part. Remember, you have one is you're getting all the money, and the little bit extra above one is all your interest rate. So you could also, and it means the same thing, is you could have taken just that number, so the 0.005, just that bit, and you can times it by the PPY and then times it by 100 because we remember how we divided it by 100. So a quick way also, you could just do that times and then times by 12 because PPY was 12 and you end up with 6%. So if you don't want to do the solve, and sometimes in exams they say show how the percentage is 6%, you're probably better off maybe writing that, what I wrote in green. But it's okay because remember, don't write solve on your paper. I'm just writing solve to show you how to calculate it on your calculator. All right, B. So here, if we have a look at B, we've got the same scenario. So here's my, there is the R value. and I'm going to use the same formula. So I'm going to say 1.012 equals the R. So, and this one is quarters, so PPY equals 4. So it'll be over 4 over 100, and you could then do solve, and you end up with R equals 4.8%. The other way I could have looked at it, you know, if I was looking at it like this, I can see that this bit is the percentage, the extra interest part. So I could have just gone 0.012 times 4, because that's PPY times 100, and I'll end up with 4.8% as well. Okay, don't need to do both in a test or an exam. I'm just putting both there because these are your notes. Quickly going to go through this question, but this is another question that you probably wouldn't be able to do technically till you've finished chapter 8, because it has a few other scenarios. So I'm going to explain it, and don't worry, we will be going over a few things that that you haven't seen yet. All right, so it says consider the recurrence relation. So you can see here that it is, because it's timesing by a number greater than 1, this is growth and it's geometric. So if it's geometric growth, you know it's like compound interest. Okay, so that's compound interest happening there. And then if you look here, you've got a plussing. That is like an additional payment, isn't it? So this is an additional payment. So then it's saying, what could this recurrence be modelling? Now, is it reducing balance depreciation? No, because the number is not less than 1. So we can get rid of that. Now, a reducing balance loan. Now, you guys, we haven't done enough of this for you maybe not to trigger. When you have a loan, you are multiplying by a number greater than 1 because you get cost. But when you pay a loan off, what do you think are you adding into that amount you owe, or are you subtracting it? So do you think that D would be a minus then, if it was that scenario? Can you see how that one? So this one, I'll just quickly, we can write next to it. It would have had a recurrence formula of RVN, but it would have been minus D because you're taking away a payment. Okay, in a perpetuity, that is a compound interest. We'll learn about this. That's a compound interest investment, but it's where whatever interest you earn, you subtract it with a payment. So we can see there's no subtracting payment, isn't there? So with this one will also look like that. It will have different D values, but it would look like that. So it's not that one. Now, an annuity is a compound interest investment. We just sometimes call them an annuity when we're giving the bank money. And what we're doing often with an annuity, an investment, so you're investing your money. So we can see that's happening because we've got a number greater than 1. And then it says with periodic additions of 500 made to the investment. Now, that looks good, doesn't it? That looks like what it's doing. So that is actually what's happening. We can see that periodic, this thing, extra 5 payments, that's the add 500, okay? And the investment part is that compound, that bit in the blue. And an interest-only loan of $10,000, it's definitely not a loan here because the payments are not getting deducted. But we'll learn about those. There are other things we're about to learn about.